Hi class, and welcome to our first week of Math 222. This first week we're going to be talking about Chapter 6, Rational Expressions. Now at first this subject is going to look like we're covering an entirely new section, but it should look very familiar to our first week of Math 221, where we're talking about fractions and numbers and things like that. This time we're going to have some expressions involved, so it's going to look a little bit more frightening, but really all of the same rules apply. Okay, so first let's go ahead and remind ourselves about rational numbers. So one example of a rational number is 5 over 3. It's just whole number over another whole number. Another example is 1 over 2 or 0 over 2. What's an example of something that is not a rational number? Well, 2 over 0. We don't want to have any number over 0. That's what we call an irrational number. Okay? So good, that's first week of your last class. Now let's spice it up a little bit by looking at rational expressions. Now rational expressions are just rational numbers, or just numbers in disguise. Okay? Why do I say that? Let's look at an example of a rational expression. We have a formula 4x minus 1 over x plus 2. Well, remember, x just represents a number. For example, x can equal negative 3. We can plug that into our equation and get out a value negative 13 over negative 1, which just equals 13. Okay? So rational expressions are just rational numbers in disguise. But rational expressions can also hide some irrational numbers. Okay, so we want to be on the lookout for these. So we want to find which numbers, if we're given a rational expression, which numbers cannot be used for x. For example, we have the equation x squared minus 1 over x plus 8. Okay, now we recall what is an irrational number. An irrational number is something that has 0 in the denominator. So we want to find out when our equation has 0 in the denominator. So all we have to do is solve this simple equation for when x plus 8 equals 0. We just subtract 8 from both sides, and we find that when x equals negative 8, the denominator equals 0. Okay, and we can verify that, plug it into our formula here, and we end up with 35 over 0, which is certainly an irrational number, not a rational number. Okay? So nice and easy. That should be a very simple thing to do. And now that gets us to defining the domain of an expression. Okay? So the domain of an expression is just a fancy way of saying the range over which an expression is rational. Okay? So if we have an equation like x squared minus 8 over x plus 8, we want to find the possible range of x values that makes this expression a rational number, basically. So we just solved that in the previous example, and we found that x cannot equal negative 8, or this will lead to an irrational number, but all other numbers should work, right? Because only x equals negative 8 led to a 0 in the denominator. So using fancy set notation, which we saw a little bit last class, we can denote this as the set of all numbers x where x does not equal negative 8. Okay? We're not going to worry too much about set notation, but basically the domain is where x doesn't equal negative 8. So that's what the domain is. Okay, so that covers our first section and a lot about rational expressions. We'll cover a little bit more in later videos.